Hello and welcome to this short session about Generative Adversarial Network, more commonly known as GANs. I would like to begin with by talking about some of the reasons as to why are GANs so popular. The answer lies in the power of its real-world applications, which include creating new photos and videos by giving in just some sort of text description. For instance, imagine you uploading the script of a movie on a website and the resulting video is available for you to download. Or you get to create completely new pictures based on their captions. This happens because of GAN's text-to-image capability. Text that I give as a user is converted into an image by the algorithms. Second application is in the gaming industry, where expensive production artists are hired to create animation avatars. With the help of GANs, it is now possible to feed personality traits of an animation character to an algorithm, and you will get suggested avatars back as a result. Next application is very relevant for the retail industry, where you have a photo shoot done for a model or a product. You could possibly take some of those pictures as input, as you see in the first column, put it together with a desired target pose, as you see in the second column, and run some GAN algorithms over it. The result will be the same model or product standing in your desired pose, as you see in the last column. Likewise, it is also possible to change existing images where either the foreground is changed while everything else remains the same, or the other way around. An example of changing the foreground is what you currently see on your screen now. You could also perform some sort of mathematical calculations on a group of photos like you see here. Now that we understand the power of it, let's try to define it. For the sake of simplicity, I have broken down the term into three obvious parts to make it easy for us to grasp the meaning of each term individually. So the first one here is, of course, generative. GANs are a specific class of machine learning that is based on the concept of generative models. Simply put, these models are the ones that help you predict the best possible outcome based on some input samples. Adversarial comes from the fact that GANs consist of two networks that compete against each other. These two networks and their adversary are extremely important aspects of how GANs function. The keyword network exists because we are talking of neural networks in this context. Let's dig a bit deeper to know how does it really work. So the simplified version of a typical GAN setup would look something like this. It primarily consists of two models. One is called generator, which is responsible for generating new data, whereas the other one is called discriminator, which is responsible to differentiate between real as well as fake data. The whole process runs as follows. We have some random variables to begin with. These random variables are fed to the generator. Consequently, the generator is able to produce a sample set of images. These images are then fed to the discriminator. Around the same time, discriminator also receives images from the real world. Now the task for discriminator at hand is to differentiate between the images received from two different sources. If it finds a discrepancy, the feedback is given back to generator to send better samples next time. As an instance, imagine that the discriminator got images of cats from both sides. Discriminator noticed that some carry images of 3 eyes, whereas others have 2. At that point in time, feedback is given to generator to not create images of cats with 3 eyes. After getting such kind of repeated feedbacks, generator continuously improves itself and ultimately reaches a point where it is able to generate images so real that the discriminator can't differentiate them anymore. Such images become the outcome of a GAN setup. As the last slide for today, I would like to leave you with some useful links for you to visit and watch how much fun it is with GAN. Thank you very much for now.